And first, I ask all of you that do you have any face any problem regarding the running of the code that I was given previously? Yesterday, I given the code, so I think you have no issue about the previous code. So today we will learn three things. So I am sharing my screen first. If it is visible to all, please let me know. Is it visible to all?
Your screen is visible, sir.
Okay. So today we will learn about the classification of satellite images, and number two, extraction of surface temperature for identification of the emission or emissivity of the temperature from the surface. So in classification part, I just tell you some theoretical perspectives of this classification so that you can get it easily. So classification of the satellite image means we will prepare land use and land cover map from the satellite image classification. So today we will learn how to create a land use and land cover map of a particular region. And classification or the preparation of the land use map has been divided into two particular method. One is supervised method and another is unsupervised method. So what is the basic difference between the supervised and unsupervised? So in unsupervised method, we have to identify, we have to uh, assign the classes of the land use and land cover to the system, and system on the basis of the spectral signature of the pixel will classify the entire image into the given classification. For example, if you want to classify the image into 5 category like built up, like water bodies, like agriculture land, and like mm, vegetation. So in this way, if you want to classify the entire map into 4 class, then you have to assign to the system that I want to classify the map into 4 class. So on the basis of the spectral signature of the pixel, the system will classify the entire map into 4 category. And from that 4 category, you have to identify that which cluster indicate which class. So it will create 4 cluster because you assign 4 classes. That's why the system will create 4 cluster, and on the based on your observation, you have to classify the 4 cluster into different classes. Okay. So in unsupervised classification, what we'll do, we will assign some classes to the system and tell him the algorithm through which we can classification of the map. So different types of algorithm has been used in unsupervised classification. So we will see what kinds of classification is used in Google Earth Engine. So this is the unsupervised classification. So you have no responsibility to classify the map or to classify the pixel. So entire process will be done in the system based on the specific algorithm. But in case of supervised classification, we are the sole responsible to classify the map into different land use classes. For example, in supervised classification, we have to identify the pixel, that which pixel indicate the water bodies, which pixel indicate the agricultural land, which pixel indicate the built up area. So here, that is my duty or our duty to identify the pixel as per the spectral signature, and we assign the pixel that this pixel is assigned as the built up, this pixel is assigned as the water bodies, this pixel is assigned as the vegetation, and so on. So in supervised classification, we are the supervisor and classify the image as per our concern. So which one is the better classification for land use and land cover? Definitely, it is supervised classification, because Supervised classification we will done for the small scale region, like a district, like a block, city block, like a municipality, or like a village. So for the small scale region, supervised classification is the best classification, and it is more or less 70-80% accurate. But in unsupervised classification, when we do unsupervised classification, if the area is very much large, like country level, regional level, or like global level, then we are not use that supervised classification. Then we go for the unsupervised classification. So up to this, is it clear to all the basic concept of the supervised and unsupervised classification? Is it clear now? Okay. So I'm not getting any response. That means all are clear. Clear. So now we first do the unsupervised classification. I'm sharing the code to you. This code will be used for the unsupervised classification. Just explain the code right now. So here I have taken taken the AOI, or the geometry, means I have created an area of interest. If you have the shape file, then you can use the shape file as the variable to get the mapping for the unsupervised classification. Then we have to collect the satellite image. So here I have taken Sentinel satellite image for the classification. Here today I will show you how different types of satellite image work for different types of land use classes. I'm showing you. Give a minute for that. Oh, it is not right. Yes, this one, I think. Okay, now from here you can see. So we have, is it visible to all?
Yes, sir.
If anyone can make it visible.
Visual, sir.
Okay. So this is the different types of satellite. So here I have taken two types of satellite. One is for USA, another is for India, because some of you have had no knowledge about the satellite image. That's why I'm telling this concept, the basic concept. So in USA, we have got the Landsat satellite images. So Landsat satellite image has been collected by the NASA, and it has been provided by the USGS Earth Explorer, and it is freely available. Okay. So Landsat have total 9 mission. Here 8 is written, but total till date 9 mission is available. 1 to 9. 6 mission is not available. The Landsat 6 data is not available because its launch was failure. That's why Landsat 6 was not available. The resolution of each pixel in Landsat satellite is 30 meter. So it is quite good resolution satellite image. But if you see the satellite image for India, it's called the LIS mission, and it was launched by the ISRO. And there are total 4 LIS mission till date, and all the data is now available freely from the Bhunidhi portal. The Bhuvan portal is now changed to the Bhunidhi portal, from where we can get LIS 1, LIS 2, LIS 3, and LIS 4 satellite data. And LIS 4 has spatial resolution of 5.8 meter. So do you have idea about the spatial resolution? If you have not, then I can show you. Please let me know quickly. If you have the idea, don't, then I go to the next step.
No, sir.
Okay. So if I put like
Sir, you are not audible.
I'm not telling anything right now. Okay. If I zoom over the satellite image, you can see this square box. This square box is called the pixel. So pixel is the smallest unit of an image. So this is the sentinel satellite image. That's why the length of this pixel is, why the length of this pixel is 10 meter. That is, this is 10 meter, 10 meter, 10 meter, 10 meter. So this is a 10 meter square. So one pixel cover in sentinel image 100 square meter. I'm telling it again. In sentinel image, the pixel size is 10 meter. That is, spatial resolution is 10 meter. That means all are 10 meter. That means the aerial coverage of this pixel is 100 square meter. But in Landsat, it is 30 meter. So if it is 30 meter in Landsat, that means it covers, one pixel cover 900 square meter. So which one is the better? 100 square meter is better than the 900 square meter, because in 100 square meter you can see object very minutely rather than the 900 square meter. Okay, is it clear how you can differentiate the spatial resolution and how which spatial resolution is best for you? Is it clear, right? If it is not clear,
Yes,
please
sir.
let me know. Okay. Now, LIS 4 has the spatial resolution of 5.8 meter. So that means it covers like 5.8 into 5.8. It covers like 33.64 square meter. So it gives more high resolution than the Sentinel. This is a Sentinel. Sentinel, this is a Sentinel. This is the Landsat. And this is the LIS. So LIS 4 of India is much better resolution than the Landsat and Sentinel. But in Google Earth Engine, LIS image is not available. That's why we are not using the LIS, because these kinds of platform are not has the access of satellite. So we basically using the Sentinel satellite image for the classification of the satellite, for the classification purpose or for making the land use and land cover. So this is one thing that I'm telling you. Now, if I coming to the bands of the satellite image. So bands of the satellite image means when you are downloading any satellite image, you will get the satellite image in different band form. So it looks like this. I'm showing you one satellite image here. If you see this Landsat band, this is a Landsat satellite image. When you are downloading the satellite image, you can get the file like this. You can get the file like this. So each and every file, you can see this file B1 TIFF, B2 TIFF, B3 TIFF. That means these Landsat 8 image containing total 11 bands. Up to this, it containing the 11 bands. Okay. So if you see this band information, you can get it from here. The band information of the satellite image of Landsat 8 and 9, you can see the 11 bands are present over here. So each band collecting each reflectance from the Earth surface. I repeat, each band collecting each reflectance from the Earth surface. For example, band 1 actually collect the coastal aerosols value. Band 2 collect the blue reflectance. Band 3 collect the green reflectance. Band 4 collect the red reflectance. Band 5 near infrared. Band 6 short wave. Band 7 short wave. Band 8 panchromatic. Band 9 cirrus. And band 10 and 11 collecting the thermal infrared. So what is the importance of the band? If you want to prepare the land use and land cover map, you have to get the information of band from 2 to 7. From 2 to band 7, it will very helpful for the land use and land cover map preparation, because near infrared band basically gives us the information about the types of vegetation and the health of the vegetation. Band 4 also give the information of the vegetation. Band 3 vegetation and cropland. Band 2 giving us the information of the water bodies. Shortwave infrared band 1 and 2, band and 6 and 7, it will give us the information of the human structure, like the built up area, roads, dam, bridges. These types of information we will get from the shortwave. And band 9 gives us the information of the cirrus cloud. Band 8 basically it is a panchromatic band, and you can see the resolution of this panchromatic band is very high, 15 meter. Rest of all the bands are 30 meter. So that's why this band is used basically for the process of the pan sharpening. I'm not going detail of the pan sharpening band. I just telling you that this band will helps to minimize the other band into the 15 meters. So 30, if you reduce the 30 meter band to the 15 meter, this process is called pan sharpening, because we will sharpening the other pixels or convert the other pixel into the high resolution with the help of the panchromatic band. This process is called the pan sharpening process in GIS. So band 10 and 11, it is a very important band for land surface temperature. If you are working with the Landsat image and you want to extract the land surface temperature, you definitely use the band 10 and band 11. Basically, you use the band 10 for the extraction of the band surface temperature. So this is the part of the Landsat. Now, if I come to the Sentinel imagery, this satellite image is under the European Space Agency, and it is available freely in Copernicus Open Access Hub. If you want to download, so you have to go to the Copernicus Open Access Hub, and you can get different types of Sentinel data. So up to this, I think it is Sentinel 1 to 6 mission is present. Sentinel 1 is basically the microwave remote sensing data. That means the radar data. So radar data basically helps to identify different types of atmospheric condition in the Earth's surface. So if you want to understand one thing, that remote sensing has done with different bands of the electromagnetic radiation. If you see this image, you can see this is the electromagnetic radiation, and these all are the spectrum. So basically in remote sensing, we use from ultraviolet to the thermal for the image processing. So up to this remote sensing is called the optical remote sensing. So when you are using these kinds of band for the remote sensing or the image classification process, that is blue, green, red, near infrared, shortwave, infrared, this is called the optical remote sensing, because these bands are the optical bands. But when you go beyond this thermal image, and you can use the microwave for the remote sensing, this is called the microwave remote sensing. And microwave remote sensing, the advantage of the microwave remote sensing is it penetrate the cloud, but the optical remote sensing cannot penetrate the cloud. That's why if you are working with the flood vulnerability or the flood water logging, then you must go for the microwave remote sensing or the CERED remote sensing. But if you are preparing the land use and land cover map, then you will have stay here in the optical remote sensing. Is it clear to all? If it is not clear, please let me know. I will make it clear more in detail. Is it clear? Please respond so that I can. If it is not, you are not responding, that means you are not understanding anything. Am I audible to you?
Yes, sir.
Yes, sir, audible.
Okay, so I'm not asking anything to you. Okay, now what we have to do? As we are preparing the land use land cover map, so we are not going for the Sentinel-1 data because it is just hard or micro remote sensing data. We are not go for that. When we are working with the flood inundation, then we will work with the Sentinel-1. So Sentinel-2 is the multispectral data. It gives the multispectral data. Sentinel-1 gives us the radar data or microwave data. Sentinel-2 gives us the optical remote sensing data or the multispectral data, where we get different types of bands like blue, green, red, near infrared for that. And this has the high resolution satellite image where the resolution is 10 meter. Each band has the 10 meter. Okay. Some bands are of 20 meter and some bands are of 60 meter, but we are work with the 10 meter bands. Now, if you go to the Sentinel-3, it basically helps to identify oceanic and land surface and atmospheric data. So if you are working with the different types of atmospheric hazards like cyclone, like precipitation, like hailstorm, you are work with the Sentinel-3 data. And Sentinel-5 data is also available in Copernicus Open Access app. So where we can get the air pollution data, Sentinel-5P data, as I told you yesterday, that Sentinel-5P data gives us the ozone, carbon monoxide, sulfur dioxide, like this. They give these types of data to identify the air pollution data in a particular region. Now, I'm coming to the practical part. So first, we will go for the unsupervised classification of the satellite image. These are the codes that I provided to you. So I have created a arbitrary region of interest, and I have taken here. Sorry, I have taken here the shape Birbhum district, and on the basis of this shape file, I have created an unsupervised classification. So in unsupervised classification, you can see I have taken the Sentinel-2 data from the Copernicus. This is the code that you have already known, and then I have filtered the boundary. Then I have filtered the date. It is very important. So when you are preparing, just remember it. When you are preparing the land use and land cover map, please try to take a cloud-free data, because cloud may create barrier against the identification of the pixel. That's why if when you are working with the Sentinel data, multispectral data, you can take the data between January to February, because at that during the winter season the cloud is very less, so you can get the cloud free data. If you have not able or able to get it, then you can use this code to filter the cloud. So here I have taken the images which have the cloud cover less than 20. If you want to make it less than 10, but don't make it 0, because sometimes what happened that there will be little bit of cloud in the satellite image. So if you make it 0, then you will not get any satellite image. So you have to give like 5, 10, you can give 2 also, but don't make it 0, because satellite image is not totally cloud free. That's why don't give 0 as the cloud percentage or remove the cloud. Now the second step is to create the median composite image, because here we have lots of image here. There you can see there are lots of images are here. So all the image must be composite into a single image. That's why this kinds of code has been used here. Now what we have to do? We have to create band composite file using this step, band composite file using this step. So here I have composite the band using band 2, band 3, band 4, band 8, and band 11. So before going to this step, you have to know about the band combination or the band information of the Sentinel. So if you go to the Google and you write Sentinel band information, sorry, if you, as I'm working with the Sentinel-2 image, so I'm getting this Sentinel band 2. You can see this is the band combination of the Sentinel, band information of the Sentinel. So you see band 2 indicate the blue, that is useful for the LULC. Band 3 is green. It is also optical remote sensing band. It is also used for LULC. Band 4 is red. It is also used for the LULC classification. And all these bands are the 10-meter bands. Okay. Now, if you go to the band 8, because I have given here band 8. So band 8 indicating the near infrared band. If you see here, band 8 is the 10-meter resolution and is it near infrared. So it will help us to identify the health of the vegetation. And now the last band is band 11. So what is the band 11? Band 11 is the square band, that is the sort of infrared band, and it has 20-meter resolution. So all these bands are the high resolution band, and these 4 band basically used for the image classification in Sentinel-2. Now, this code is used to composite all these selected bands over here. Now, coming to the step 4. If you see the step 4, here we use the k-means clustering methodology to make the unsupervised classification. Is any question? So here k-means clustering method has been used to classify the images, because k-means clustering is the popular clustering method. If you are using the SPSS or statistical software, any statistical software, then if you want to make the clustering any component, then you will use the k-means clustering, because it does not disturb any other like noise or like other information of the bands. That's why we're using the k-means clustering. So here we have applied the k-means clustering under 5 classes. So here I have created the 5 classes. You can make 4, 3, 2, 5, 10, whatever you class we want to make it here. So here we have trained the sample. Sample is the signature of the pixel from the satellite image. Then the number of pixel I have taken as sample as 5,000. You can take more or less. Then we run the cluster by this code, that is e cluster dot weka means, that means the k-means cluster. Weka k-means I have taken 5 classes and trained the training sample. That is, training means this variable is the training variable where I have used the sample of 5,000 pixels. So you can take more than 5,000. So now we rescaled it as cluster, and then if you want to visualize this map, you have to keep this code where we use the palette for the 5 classes, like red for built up, green for vegetation, blue for water bodies, yellow for agriculture land, and purple for fallow land. Now we can make the unsupervised classification, and to visualize the map, we have used this code map.addLayer cluster VIS params unsupervised classification. If you run this classification, you can see the result. The result has coming here. So how you can see the result? You go to the layer, switch off your layer of district. The internet is slow, that's why it coming in late. Up to this, is it clear to all? So it's not coming. So I'm trying it to the another code, the same code with another region I have. Give a minute.
Yeah, it comes as a image.
As the image, okay. You have to classify this image. Just run that code, then oh, it's not supervised classification. Unsupervised classification is here. So run this. Actually, the net is very slow. That's why it's not working. You can see the classification is coming in a strip. If it is completely loaded, then you can get see the classification here. This will be your classification. Wait for a minute. So this is the classification that you have made to the unsupervised. And then what will be your task? You have to identify the color and the object. For example, just a minute. Okay, so if you want to classify the image, you just see the color and check the object from the real earth. So if you switch off this layer, you can see this is the water body. So which color indicating the water body? You just see this is the water body. So you have to make the color, this color as blue. And this blue, what indicating the blue color? Blue color is like, if you switch on the satellite. So don't make it for your smaller region, okay? So it's only helpful for the larger region. Unsupervised classification is not for the smaller region. So this is the water bodies. So you can change the color from here to the water body. This color is water body. My internet is not stable today. The entire running process depends on your stable internet. So make sure that your internet is stable. So you can make your color from here also. So in this way, you can change the color, or you can change also color from here also. So here we use different types of color. So here I'm right now don't use any color. That's why the color is by default color here. So you can change the color from here and from code also. You can here see the random visualizer. That means I have not used any color. Randomly it creates some cluster, 5 cluster. It created 10 cluster here. So we have to identify what is the color indicating in this particular satellite image. So in this way, you can get your unsupervised classification. But I request all of you that don't use unsupervised classification in your study area, because I think your study area is not so big. That's why you are not using these kinds of satellite image classification. So for the smaller region or for your area of interest, you make use the supervised image classification. So it is clear to all. If you are run this code for your region, you can get your unsupervised classification. we can make it, and if you face any problem, let me know. I will try to make it clear. So now yes.
Sir, as you told, like unsupervised classification is not for smaller regions. So if my study area is like a city, so then what can I
City
do?
is not a larger region. City is a smaller region.
Yeah, so then unsupervised will not work.
Yes. So unsupervised classification will work, but the accuracy will not so much high.
Then what should I do
You
for
go for
that?
the supervised classification.
Okay.
So now we will learn how to do the supervised classification. This is the next exercise. So any question up to this unsupervised classification? Okay, now I'm going to the supervised classification. So supervised classification basically will be done by us. We are the supervisor and we create a training file to classify the whole satellite image. So here I have the code of the supervised classification, but this code will not automatically run. You have to select some training feature, then you have to run this code. Zero chat box, this one. I have to give into I have given to you. Now, to make the supervised classification, so I told you repeatedly that you are the supervisor and you have to select the sample from the map. For example, I have selected this part as my study region. Just a minute. I'm using this area for the supervised classification. So here I have used one of my study area for the supervised classification. And for this supervised classification, what we have to do? So this is my supervised classification. So here I am not going for this code. I just show you this code, supervised classification. So you can see this is my region of interest. And first you have to demarcate your class. For example, I have taken the classes like water, vegetation, agriculture land. Okay. So 3 classes I have taken to show the satellite image classification. So for that, you have to, the step 1 is the load Sentinel-8 data. Here, Sentinel-8 data has been taken for the supervised classification. You can take also the Sentinel-2 data also. So here, sorry, here Landsat data has been taken here. You can take also the Sentinel data. So here the Landsat-8 data has been attached here with this code, and we filter the date using the filter date and filter the boundary using this variable, and we sort the cloud cover and make the first. The first means we have to make the clipping of the area of interest. Then we visualize this parameter like we have to composite the band over here. This is the steps to composite the band into band 4, 3, and 2. That means the false color composite band has been prepared here. Now, the third step is very important step, that is creating your training data. So to create your training data, what you have to do? You have to create here marker data. Okay. Suppose this is your satellite data. If you want to, suppose this is your vegetation data. First, you have to take sample vegetation pixel from the each part of the study area. I repeat, you have to take some sample points over this region as the vegetation for your classification. Not all the vegetation you have to take, but some sample of the vegetation you have to take for your study area. So how we can take the sample? So this is the marker. So if you click on this marker, you can get a new layer. It is called the geometry. So you have to change the name of this geometry as like vegetation. As one vegetation is there, so I have taken vegetation 2 like this. And import as feature collection. Must change this geometry to feature collection. Don't make it geometry. Otherwise, the code will not run. So convert it into the feature collection. Click on the property and write it here. LULC and value is 1 like this. So now you can change the color as it is vegetation, change the color as green. And where the vegetation is present, click that one, 1, 2, 3, 4 like this. You can take randomly from your study region the vegetation pixel. Like this is my, if this part is in your area, then you can take this as vegetation. Okay, so in this way you can take the vegetation here. So is it clear to all? So you can see the vegetation variable has been prepared over here. So if the vegetation is completed and if you want to take the agricultural land or other feature, what you have to do? You have to create the another new layer from here and click on the settings and write the name as built up and import as feature collection and properties as LULC and value is 2 because vegetation was 1, built up is 2. Now change the color of this particular feature. Click OK. New names and the alphanumeric. Okay, don't use the space over here. So if there is settlement over here, for example, you can see the variable built up has been prepared over here. Okay. So in this way, you can take the new variable for your classification. So if it is built up area, so click on this 1, 2, randomly from your study area.
And
Don't
the
take,
value will change. Like for water, but for vegetation, the value will 1 and the water body's value will 2.
yes, yes. Don't do it, don't do right now because you have to make accurate classification. So make it in after the class or tomorrow. So click on this like this. So after getting this, all the variable like this, so I've deleted the variable because I have already prepared the variable here. So I have created the variable water, vegetation, agriculture for the study region. After getting all these variable as per your concern or as per your study area or as per your objective, then go to the next step. Okay. So I am taking us on the study area map, supervised classification. I have taken on the basis of a safe file. So I have taken here 4 classes: water bodies, built up, vegetation, and agricultural land.
How many samples we need to take?
Yes,
How many samples we need to take?
it is as per your area. If your area is very small, I have taken here 24 for water bodies, 24 for built up, 15 for vegetation, and 24 for agricultural land. So how many sample you will take depends on your area, depends on your availability of the feature. Okay. More the sample you take, more the classification will be more correct. Less the sample you take, the classification is not more correct. Okay.
Oh.
So here I have taken 1, 2, 3, 4, 4 sample over here. Water bodies, built up, vegetation, agricultural land. After getting the sample over here, we have to make all the classes into a single class, that we merge all the class. We merge means we merge water body with built up, with vegetation, with agricultural land. So we have to create a training file for each classes. Then we merge all the training file into single class. I repeat, first we need to take sample from each classes. That is called the training sample or the training file. And then each training file for like the training file of the built up, training file of the water bodies, training file of the vegetation and agricultural land, we merge all the training file into a single class. That is called the class name. This variable is called the class name because class name variable will help us to merge all these collected sample pixel. Then we have to define the band combination of the satellite image. Here I have taken Sentinel-2. So here I have taken the band 2 blue, band 3 green, band 4 red, band 5, band 6, and band 7. So band 4, band 7 means 4, 5, 6. That is near infrared. All are the near infrared, and one is short wave infrared. So I have taken these satellite bands for combination of the false color, for the false color combination. And then this is the steps that feature collection that we have prepared for the each class, that I am telling you that you will not taken the geometry. So here I have taken the feature class. So this feature class will help us to identify the other pixel. Based on the pixel, based on the sample pixel, the entire classification will be done. I repeat, based on the sample pixels, the entire classification will be done. So for that, we train the model as training data, and here we have take the method of smile card. Smile card method is a machine learning method. So here I am used the smile card method, and this method will gives us very accurate land use land cover classes. And before that, you have to filter the training data first. You have to make the class the name of the land use land cover. Then consider the resolution of the satellite image. Here I have just taken the scale as 10 because the spatial resolution is 10. That's why I have taken the scale as 10. So after completing all these, you have to classify the map as clipped, because I'm not taking entire tiles. I want to take only the classification under my area of interest or under my save file. So here I have used the classifier command for the running of the particular land use land cover, and I use 4 palettes, blue as water bodies. This is also water bodies. The red for like built up, and yellow for agricultural land. And now if you run this code, you can see the result. If we zoom on this area, yes, it's coming. So this is the supervised classification. And it is a very much accurate classification. You can see here. And if you want to validate, you can switch on your satellite. If you want to see this is the built up or not, you can see it easily from here. So this is a built up, and if you switch, if you want to see this, you can see this is the built up area. And you can see this is the water body, blue is water body. If you switch off this, you can see this is the water body. Because I have taken the sample pixel of the water body. On the basis of this sample pixel, it create a new map for there. But here the water body is not visible because the spectral reflectance of this particular water body is less. That's why it is not coming in this classification. So in this way, we can make supervised classification for a particular region for your concern. So please, first you have to do that, create your area of interest. Then you have to download your satellite image, then filter the image, filter the date, filter the cloud cover, then create your training file, then merge all the training sample file. Then you use the smile cart method to classify the whole images. Okay, so this is the process, so that we can through that we can make our supervised classification maps. So if you have any question regarding the supervised classification, you can ask me. If you have no question, then you can try it in your system, and you can see the result. Don't make change code. You just change the some specific places where you need to change the code, but not entire code. So I have given to you the supervised classification code in your chat box. I think you all of you get it. This is the supervised classification code. Now I want to switch over the next part of this training. This is extraction of the surface temperature.
Excuse me,
Yes, yes.
sir. You have just now shown the misclassified pixels. So, is there any way which we can change the misclassified pixels to those correct pixels?
Yes, yes, yes. You can change it. You can change it from this particular. If you have not satisfied with this build up, then delete the build up and prepare a new build up from this particular geometry input. Okay.
Sir, there is one record tool in the AirDAS which we can use to change the pixels. So, is there any kind of similar tools here in Google Earth Engine as well?
You want to change the pixel? I don't understand your question.
Yes, sir. You have just now shown that the water bodies is being classified to another land use category. So that particular small water bodies, if I wanted to change it to water bodies from that other class, so can I change it? In AirDAS, we can change it through the record tool. So is there any alternative that we can change, like record in Google Earth Engine as well?
Okay, just 1 minute. I understand your question that if it is a like false color composite. Okay. So what you want to tell that if you want to change this, suppose this is the pixel of water body. Okay. This is the pixel of water body. Am I audible?
Yes, sir.
So what you want to do?
Sir, if it is wrongly classified, like,
Okay, I understand. If it is wrongly classified, then
yes.
I think you cannot delete it any one particular point. You have to delete the entire things here from here. You have to delete the entire variable. Or
Okay.
otherwise, you can
Uh,
do that. No, I think it is not. No, you cannot delete any one particular pixel from here. That getting done in ADAS on ArcGIS also, but in Google Earth Engine it cannot be done. So there are some limitation of this software also.
okay, thank you, sir.
Thank you. So this is the supervised classification you have learned, and I think can all try it in your system and let me know. But please make patient until you satisfied with your classification. So now I'm going to the next part of this classification, that is the land surface temperature extraction. So what is the land surface temperature? So land surface temperature is basically the heat emitted from the surface during night time or during daytime also. So if you are working with the urban heat island or like the climate change or global warming, you can use these kinds of study, that is a land surface temperature study. So the best thing in Google Earth Engine, you can make the land surface temperature from the MODIS data. And the speciality of this MODIS data is this satellite collect the emissivity data of the surface in 3 times in a day, 3 or 4 times in a day. I think it is in morning 5:30, then 12:30, then 4:30, and then night time. So 4 times data you can get from the MODIS data. So it gives the daily basis data. But if you are using the Landsat data for the surface temperature, you will not get the daily data, but you can get the monthly data as per the availability of the satellite on your particular region. If the satellite is not available on that particular time, you will not get the data of the land surface from this Landsat imagery. Okay, but MODIS data, you can get the diurnal surface temperature change, and you can calculate the urban heat island also. So this data is very much useful for the land surface temperature emissivity, but the resolution is not so much high. But the spatial resolution is not so much high, but the temporal resolution is very much high because it gives the diurnal data. On the other hand, if you take the Landsat for the surface temperature, the spatial resolution is high, but the temporal resolution is not high. So what images you use for surface temperature emissivity, it's depend on your requirement. If you want to get the high temporal resolution data, then you go for the MODIS data. If you want to get the high spatial resolution data, then you go for the Landsat data. Is it clear to all? That means if you want to make the changes in different daytime during summer, then you must go for the uh, MODIS data. But if you want to changes in different season like winter, pre-monsoon, monsoon, or summer, then you go for the Landsat data. So I'm interested in high temporal variation or high temporal resolution. That's why I'm giving you the land surface temperature from the MODIS data. So here, so MODIS data is basically 1 kilometer spatial resolution. So 1 pixel covered the 1 square kilometer. So it is large pixel. So that's why it is not so much high spatial resolution. So for that, I have taken my district as a shape file here. And here step 1 is to import the land surface image collection from the MODIS data. Here I have taken the MODIS data here. So if you want to get the MODIS data, you can write it, simply write MODIS. So you can see this data is the Terra ocean reflectance daily global 1 kilometer. We are not taking this because it shows the ocean reflectance. We need to take the surface reflectance. It is 8 day. You can take this data. daily 1 kilometer. So you can take this data for your reference for your study. So here I am using this code for this data, and here I have to take the date from the January to December and filter the date, and I have select the land surface day 1 kilometer because it shows the 1 kilometer spatial resolution. If you want to open this, this is 1 kilometer spatial resolution data is here. So here I'm using the 1 kilometer resolution. And the second step is the data that collected in the satellite is in the form of Kelvin. So we need to convert the Kelvin data to the Celsius by 0.02 and subtracting the value of each pixel from 273.15 degree centigrade. So this value will help to convert your data into Kelvin to centigrade. So now coming to the next part of this. If you want to make chart for land surface temperature analysis from January to December of your study area, you can use this particular this code to identify the line graph for your study area for the changes of temperature in a daily basis. Okay, so this is the code I will also given to you. Now the next step is the visualization of the image using my shape file that I'm using it here. So I'm giving it the code to you first. This is the LST code, you can save it. Now if I run this code, you can get two things. One is the graph and another is the map. So I switch off this layer and wait for the map. The map is not basically colored map. This is a black and white map, so I'm make it color. So before that, I am going click on this zoom tool to get the line graph. So you can see from day 1, January 1, then January 2, then January 3, here 4, 5, 6. You can get daily data and daily diurnal changes of temperature from January to December. You can see in our region, the maximum temperature is between May to April to June. Like May to April is the highest temperature, and due to the monsoon season, the temperature has been dropped over here, and during the winter, it is also dropped. And you can see there is no continuous line because the temperature has been break over here. Because if the diurnal change is so much acute or high, then you cannot get any trend line in this particular image. You just get the dot over here. You can get the dot and click, and you can get the temperature in July 21, 29.007 degrees centigrade. August 24, 23.93. So in this way, you can get the data also from here. So if you get this color from this image, what you have to do, you click on the layer, click on the LST because it is the mean temperature of the entire year. Annual mean temperature, it gives the map. So map basically indicating the annual average temperature. So if you want to get the color, click on this grayscale and click on this palette and make the color like this. Red is the highest temperature. Then, sorry, this red is like low temperature. Then make some high. And then make some high. Three classes I can make it. If you click on apply, make it stretch 100% and click on apply. Okay, so here I have to give some more classes. Close it. You can see the variation of temperature is here. So, but in this specific district, this part, the western part, is the part of the plateau fringe area. So plateau fringe area is experiencing the highest temperature rather than this agricultural land. So these are all the agricultural land, and eastern part is not flat land or the alluvial plain. That's why the temperature is less, and the western part has the temperature is highest temperature. So if you get this inspector tool and click this deep red, you can see the temperature is 32 degrees centigrade. And if you click on this part, it get 28 degrees centigrade. So in the eastern side of this particular region is less temperature, and western side is highest temperature. Okay. So in this way, you can get temperature variation or spatial mapping over the LST mean. That means the annual average temperature of the region you can get as a map, and you can use for your further study. And you can also use your like line graph for your reference, that these are the changes of temperature in different day, in different month from January to December. So in this way, we can get the land surface temperature. Now, okay, so up to this, if you want to get only the graph, then you can use this code. I want to get only the graph over here. If we run this, we can only take the graph of mean LST, and graphs is for 2010 to 2020. 10 years temperature change in this particular district. 10 years temperature changes, you can see over here. So it indicates the mean land surface temperature per day. For example, in a day, it collects 4 time data. So in 4 time data, we can get the mean data in a day. So in 9th of January, we can, or 2010, we can get 23 degrees centigrade temperature. And here we can get 41 degrees centigrade temperature during the 17th of May of 2014. So you can get the information of the global or the regional temperature changes from these kinds of study. So I'm giving this code to you. So today this is all from my side. So if you have any question from your side, you can ask me. If you have any question from your side, you can ask me.
Sorry, sorry. Yesterday I missed the part of inserting this shape file in the Query engine. So how to insert this shape file?
Okay. I'll show you. I think I shared the code to you. Did you get it? So these are the code through which you can visualize your shape file here. So if you run it, you can visualize only the shape file. So I'm giving the code again. So it is, you can use this district level shape file. Or if you want to import your shape file from your computer, then you have to go to the asset. If you want to import your shape file from your system, go to the asset and click on new and click on table upload, shape file upload. So you have to upload these kinds of file from the shape file, .shp, .dbf, .prj, .shx, .cpj, .fi, and .sbn. So all file you have select here and click on upload. It will automatically upload to your Google Earth engine. Okay.
Okay, sir.
So any other question from your side? I think you should make practice. And if you are working with long time, 7 days, from 1 to 7 days, you will get all the information about the Google Earth engine. It is not so much tough. And you can
And
get the,
sir,
yes, yes.
one more question, sir. Sir, this Google Earth engine, does it work with the Landsat 5 images?
Yes, yes, yes. You just take the satellite image as Landsat 5. Okay. So if you
Okay.
get here Landsat, you can see the Landsat 3, Landsat 4. Like if you want to take the Landsat 4, just click over here and take this code. Take this code,
Okay.
then paste it here where it is. If you want to make the false color composite, I'm showing you. Just change the satellite bands. This one, just copy and replace this band to this. Okay.
Okay.
So I deleted over here and click on run. And you can see this image is the image that will appear right now will be the image of the Landsat 4. Just I'm showing you. The internet is slow, that's why it's not coming, but it's coming here. Okay. So you can use this code from this particular copy that code and paste it into the images. Okay.
Okay. Okay.
So any other question? Okay, now Snazis, are you here? Snazis, are you here? Snazis? I have shared all the code. Oh, sir, what do you want to know? Ajay sir, what code you want to? Oh, this code, na?
Yeah. Basically, the GE could directly share the Google Earth Engine file, sir. Don't
Oh,
paste
this
any
one.
step by step, sir.
Okay,
Basically,
okay, okay.
need the GE
I'll
file.
share. I'll
Yes,
share
sir.
it to you. Okay, okay, okay. So okay, I think Snazis is not here. So today I have done. So tomorrow we will learn some more things like remote sensing indices, drought indices, and the flood inundation. These three things we will learn by tomorrow. So after tomorrow, if you have any query or any other working with the Google Earth Engine, you can contact with me through mail or through WhatsApp. Okay, so no issue about the further learning. So okay, thank you all and good night to all.
Hello.
Yes, ma'am.
Yeah, can you share your mail ID, sir?
Okay, sure. I am writing it here.
Okay, thank you.
So I am giving it here. So thank you all. Thank you for your present. And tomorrow will the last class. And tomorrow we'll learn some remote sensing indices and some relational analysis with the indices. We'll learn tomorrow. So thank you all. Thank you.